Well, hello. So, what we're starting here is a new unit on sequences and series. This unit, this topic, is newly added to Math 124. Um, in this video, in fact, this upcoming class, it'll be just sequences. So, sequence. Good. Right. Broadly defined, a broad definition of a sequence is an ordered list of items. An ordered list of items. For example, the planets. Planets in our solar system. In order from the sun, the order is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So the planets in that example is a sequence. Another example of a sequence outside of mathematics would be the presidents of the United States. Right, there's a first president, George Washington, a second one, John Adams, a third president, Thomas Jefferson, and so forth. So those are real world examples of sequences. Getting a little closer to math, how about the alphabet? When we talk about alphabetical order, A, B, C, D, E, F, G, etc., etc., that is a sequence. Those symbols and names form a sequence. The most basic and my favorite example of sequence in mathematics would be the counting numbers 1, 2, 3, 4, 5, 6, 7, and some following that. That's an example of a sequence. Now, when we talk about mathematical sequences, we're talking about quantities, numbers, and so for example, here is the counting number sequence starting off, and we'll have the infamous three dots, meaning the sequence goes on without a predetermined end. Each one of these members, each one of the items in a mathematical sequence are called terms, Terms. And recall, just keep in mind that a sequence is an ordered list. So there's a first term, and what the mathematicians standardly use is a kind of shorthand or abbreviation. The first term in a sequence, they'll use the letter A, small letter A, with a subscript, the number 1. In our counting number sequence, the first term would be 1. So A sub 1 equals 1. A sub 2 equals 2. A sub 3 equals 3, and so forth. Now, there you can continue this process, and there'll come a time when we'll call a term the general term. A sub n equals n. In this example, the little subscript equals the actual number, and we'll see examples where it's a little more complicated than that. But there's a general term, which gives you kind of like the overall pattern, and it uses just the letter n. Sometimes it's called the nth term. I'll use those interchangeably. They mean the same thing, but I kind of like both. General term or nth term. Now let's look at a problem where you're given a general term, and we need to write out some of the actual terms. So give me a sec here. Get this little reposition. For example, one of the type of problems will give you a general term, looks something like this. So a sub n equals 3n plus 1. So that's a general term, and we'll be called upon to find some of the terms. For example, the first term, a sub n, what we'll do is simply substitute the number 1 every place where there's an n. It's really that straightforward and mechanical. And you just compute as necessary. We have 3 plus 1, and that's 4. All right, great. What about the second term? That would be called a sub 2. And we're just going to follow this rule here that was given. The general term kind of gives you a rule, a pattern, and you're just following it. It really is that straightforward. 3 times 2 is 6. We're talking about 6 plus 1, and therefore the output is 7. Great. How about the third term? A sub 3. Putting in 3 for n. Follow the rule, and you get a number coming out. Turns out to be 10. And if that were it, we might list the sequence here. We have found the first three terms of our sequence, and we'd write them in orders 4, comma 7, comma 10, like so. Let's see now. Let's try a different pattern. Just trying to get a variety so you won't be completely blown away by the problems that I've put on Canvas. Give me a sec here to get another example here. All right. Okay. How about the general term to be given is a sub n equals 2 to the nth power. So it's an exponential. And so that's the general term, the general pattern, if you like, or sometimes called the nth term. And the first term would be a sub 1. So you put in 1 for n. Often there's be a little bit of simplification or computation to do, and so we'll do that. We would say the first term is 2. And then how about the second term? A sub 2 equals 2 to the second power, 2 squared, which is 4. And there's a sub 3, the third term. That's 2 to the third power, 2 cubed, which is 8. And finally, a sub 4 is 2 to the fourth power, and that's 16. And in the answers, I'm deliberately having them written out as a sequence in left to right order. So you have 2, 4, 8, 16. And you might be asked to find a later term, sort of out of sync here. Oh, a to the, I don't know, 10th power. So that would be 2 to the 10th power. And let's see, if I were to give you a number that big, I'll have as a note what 2 to the 10th power is. So you don't have to try to figure that out. But it would equal some number here. And if you're really stuck, and I messed up in my problems, whatever, just leave it as 2 to the 10th power. That will indicate that you're seeing that there's a connection between the term number and how the letter n, or the number n, will show up in the expression. Let's try a different look. Remember that we just dealt with a unit on logarithms and exponentials, and let's have a different color just for that. So here we go. What if the general term looks like this? A sub n equals 10 to the nth power. Well, the first term would be 10 to the first power. And then for a little bit of computation, we just write that as 10, or simplification, I guess. Well, what would the second term look like? A sub 2 would be 10 to the second power, which is equal to 100. And how about one more? A sub 3, that's the third term of the sequence, and that would equal 1,000. So we might write the sequence as 10, comma, 100, comma, 1,000, something along those lines. So that's all well and good. For a last example, how about logarithms? Let me get another sheet here. All right. Okay, so how about if the general term is a sub n equals log of n? And let's just write this out so it doesn't look so imposing. A sub 1, you're just going to put 1 for n. Okay, we'll leave it for the time being. Many of these, as we'll see, there's nothing much more we can do without calculators and all that. The second term would be log of 2. Notice that the n is being replaced by an integer, a positive integer, and that's going to be the case in what I do here. Here the third term is log of 3, and I think you're seeing a pattern here, but maybe it would be interesting. What is the 10th term? Well, the 10th term is log of 10. And let's come back and say, is there anything at all that reminds us maybe of some facts about logarithms? Specifically, that's I'm thinking about the first and the 10th term. I hope there's a little bit of a memory that, log base 10 of 1, that equals 0. That was one of the log properties. Now, log of 2, log of 3, base 10, nothing we can do with it. We'll just leave those. However, again, I hope there's a little bit of a memory that log base 10 of 10 is equal to 1. That was another one of those log properties. So I think it's kind of neat that we get a little bit of rehearsal in the logarithms. Now, how would this look like as a sequence written left to right? Well, let me do this in them. Let's do this in red. Why not? Okay. So one way you could write it is log of 1, comma, log of 2, comma, log of 3, comma, dot, dot, dot. That's perfectly fine. So notice, yes, there's log involved, but it's very tidy in terms of n is representing the the placement, if you like, of the term. And we could, if you like, and I won't be too fastidious about this, could have written this as 0, comma, log of 2, comma, log of 3, just representing the fact that log of 1 does equal a special number, 0, but that's really icing on the cake. Let's see. Will that do it? Not quite. There's one other issue, but I'm going to make that a separate video. So I think where we're going here is 3 videos on this topic of sequences. All right, thanks very much, and see you in the next video.